Thanks for your patience. As was often said, teamwork makes the dream work. So thanks for the help to the other folks here. So as Crope said, I'm Bob Callaway. I'm the chair of the TAC, as Brian mentioned, as well as a tech lead and manager at Google. Given the time here, unfortunately, with not being able to use my laptop, I won't be able to show you my demo that I had prepared, but we'll go through the slides anyway. But happy to show it to folks afterwards as well. So I won't bore you with a ton of information about why we're all here. Hopefully it's glaringly obvious with the intro talks as well as just what's been going on in the broader market. Supply chain security is super critical to not only open source, but the overall software industry at large. And so if you think about the SONA type reports that are great, have great information in them, and people love to quote them, point that attacks have been going up and to the right, and these are not the types of up and to the right charts you want to present to your execs. These are bad, right? But SolarWinds, CodeCov, again, not trying to throw shade at anybody. Doing this stuff is hard, and unfortunately, attackers are taking advantage of it. And kind of the last point here is there's unfortunately probably more to come, but that's why we're here today, and the OpenSSF is trying to do what we can to solve this. So in the market, if you guys read blogs or look at Twitter or are trying to figure out how do you actually secure your supply chain, you'll hear a lot about the terms on the right, like, hey, SBOMs play a role in this. How do I do SALSA? How do I generate build provenance? I've got these artifacts themselves. How do I secure them? And digital signatures often come up as a technique to verify the integrity and the authenticity of things that we look at, which is totally true. Digital signatures have been around for decades, but they're not really widely used across certainly the open source landscape, but also a fair bit of the commercial landscape as well. And if you think about why is that the case, it's not necessarily that we need new crypto outside of post-quantum concerns, but it's really around the usability of the tools and many of the other problems that are associated with using digital signatures, namely key management, what I'll talk about here in a second. But just to think about this in the context of, in order to solve your supply chain, not only do you have to generate all of these things, you have to figure out how do I sign them, how do I transmit them securely to the consumers of what I'm building, and then figure out how do I tie that all together. And that's a really challenging problem statement. In addition to that, I mentioned the key material that's associated. A digital signature, you need it's based on public key cryptography, right? So I need a private key that I keep to myself, and I need a public key that I then distribute out to any of the consumers of the thing that I've signed. Well, distributing that artifact, you'd think, oh, that should be pretty easy. Well, it turns out it's not as straightforward often as you might think. And we've seen innovation coming out of the PGP community several decades ago to try to solve this with key servers. We've seen key material posted alongside artifacts on a web server and allow people to download it at the same time. Those are all approaches. They have drawbacks to them. And even figuring out how do I store the private key that pairs with that public key that I might distribute is also hard. If I just put it on my laptop here that didn't work, well, what happens if that gets stolen, right? All of a sudden now I've been compromised. Somebody may have that private key and may be using it to act as if they're me. They're taking over my digital identity to make assertions about the integrity of artifacts that I might be generating. So figuring out how do I store that, there are UB keys, there are HSMs, there are different approaches to this, but fundamentally, again, going back to all of these documents and all of the user experience and the tooling around this, leaves quite a bit to be desired. And with Sigstore, we really wanted to take a step back and really look at this problem holistically around digital signatures, not invent new crypto algorithms, but really take a look at some of these other challenges around developer experience, user experience, and say, how can we make this fundamentally better? But as we got into that and we start to look at a lot of the proliferation of things like containers and Kubernetes, you start to break this apart and you even go like the trivial example of Bob signing something that you put onto the web. Well, how does this work in say a container environment? I go in to deploy a Helm chart. I have to think about who maintains the chart because it has references to other software that it's going to pull down. Who published the base image for that container? Who actually operates the repository and maintains the credentials? So when I say identity, all of a sudden it becomes really complicated because now I have multiple actors that I need to understand their relationships to one another, and I need to know how do I empirically verify that they're doing what they should be doing in the context of signing all of this content that's out there. So ultimately, when you look at this, it's super complicated. The good news is that the industry has been evolving in multiple different threads over the past decade plus. And so some of the things you see here called out in the circles are just examples of technical innovations that are largely being driven out of open source that Sigstore has gone and looked at, evaluated, and said, hey, there might be a way that we can actually integrate these different technology pieces together to fundamentally reinvent the user experience and the developer experience around digital signatures. And so when we look at everything from that last slide where I have all of those containers with all of those identities, how about if I actually just remove the human element completely and I could actually identify the workload itself and give it a cryptographic identity that I could then track against. Taking humans out of the equation obviously has a lot of benefits from a privacy perspective, so there's some goodness there. There's been a lot of innovation at the hardware layer of putting TPMs in computers and having the ability to remotely attest to the state of a server that's operating a particular workload, so there's some goodness there. Certificate transparency, a project started out in the open. Google and Cloudflare and many other companies have contributed to this, has done a lot to actually bring light to how TLS certificates are issued for the web. So whenever you open a browser and you see that little green lock at the top, that's actually calling out to certificate transparency servers behind the scenes to verify that those certificates are A, not misissued, and B, are the same things that everybody else on the internet is fundamentally seeing, so that you're not vulnerable to what's referred to as a split view attack. And then finally, we've seen other innovations within the CNCF around projects like the update framework, which really have taken a holistic look at the security model for how do I actually update software. It's being aggressively used in a lot of automotive use cases. So if you think about your popular next-gen car that has a ton of software that's being downloaded and updates are done over the air, we need to figure out how do we update that car securely. You can think of a lot of doomsday scenarios where an update might go bad and catastrophic things might occur in relation to that. So when we look at the market, again, don't need new crypto, but we have all of these new pieces. And with Sigstore, we wanted to bring all of that together to try to re-envision the problem. And we took a lot of our inspiration in the very early days. Luke Hines, who was the original founder of this, and then Dan Lawrence and myself got involved in the very early days and said, what should our North Star be for this project? And really, we took inspiration from Let's Encrypt, who did an amazing job in helping to proliferate the use of encryption across web traffic. And the way that they did that was through what I would argue is three main principles. One, they recognized that they needed to issue certificates in a completely frictionless way. The existing certificate authority market that was out there, you could get a certificate. It was expensive. It took a fair bit of time. Oftentimes, if I wanted to get a high-grade certificate, I had to send in a passport or other personal identifying information to that CA. They would have to verify it. It takes a lot of time. And in addition to that, it wasn't automated, right? I had to wait weeks in some circumstances in order to get a certificate pushed back. And so what the folks at Let's Encrypt did was really try to re-envision the TLS market and say, how do I make it super easy to get a cert? How do I keep them up to date? And then also, how do I drive the length of those certificates down to where they're only valid for 30 days rather than being valid for 10 years? So that notion of being able to rotate through your keys gives you added assurance against compromise in the sense that if it is compromised, well, the window where that key was fundamentally valid is already narrowed from that 10-year mark. So there's a lot of benefits that came that Let's Encrypt brought. And we said, hey, if we could do for software signing what Let's Encrypt did for TLS, the world would probably be a lot better place. So that's really what was our inspiration here. And so let me go next and say, like, what is Sigstore? The easiest way to think about it is it's not just one thing. It's an umbrella term that describes a set of projects, a set of services, as well as a community that's working on both of these different groups of things. We've got a couple different projects that I'll go through in a little bit of detail. We have several services that we are running as public good instances. They are, again, in the spirit of Let's Encrypt. They're free, easy to use, automatable, and community operated, which is another interesting twist to this, because if we were trying to set up a centralized trust root that only one company, whether it be Google or Intel or anybody else, people would be rightfully skeptical around how does that model actually scale? Why should I trust one corporate entity? So we knew from the very early on that we needed to do this in a fundamentally community-driven way and be very neutral about how we actually operate these services. So we've taken that spirit and actually built out a cross-vendor operations team with SREs. We have an on-call system that we're building out. We're trying to get to the formalizing SLOs. Hopefully we'll have some big announcements coming later this year around that. But we're really trying to, again, do this in the community way because we think that, again, open source will shed light on this problem. We'll be able to bring transparency to this problem space, but we'll do it together as a community and learn a lot and ultimately hope to raise the tide for everybody else as a part of this. And what we've seen in the community after joining the OpenSSF, this project has just exploded. We're now ranked in the top 25 projects across the entirety of the Linux Foundation, which, again, haven't even been alive really for 2 years yet. I mean, we're getting very close to the 2-year birthday. So that's been a pretty aggressive set of folks that have joined in, donated code, donated their ideas and input. And we have a set of, a very vibrant community. We've got several SIGs that exist. So I would give my final call to action. I'll encourage you to go take a look. And if there's an area that you would love to get engaged with, certainly we would love to have you as part of the community. So again, I talk about Sigstore, it's a set of tools, it's a set of clients, it's all these different things. Okay, cool. We'll go into detail in terms of all the minutia and the crypto and everything behind it in a second. But where is it being used today? And so I've given you a little bit of a snapshot as to different parts of the ecosystem that are coming and independently evaluating what is going on in the Sigstore community, saying, hey, does this make sense to integrate in with what's going on with Kubernetes or what's going on with Python? The Maven Central folks are taking a very deep look at figuring out how do they integrate it with their package repository. We have the NPM community that recently posted a request for comments to say, let's evaluate how we could use Sigstore as the fundamental signing and verification logic for the entirety of what's served out through NPM. So these are not onesie-twosie projects. These are major communities that serve a massive amount of substrate for the open source ecosystem at large that are engaged and looking at what we're doing with Sigstore. We also see a number of corporate entities productizing the work. So I mentioned here Red Hat, Nirmata, this is the company behind Caverno, as well as VMware, just 3 examples of different companies that have productized capabilities out of Sigstore. So again, tons of stuff going on in terms of both corporate entities, other open source ecosystems, all coming together to figure out how can we really use digital signatures in a much more pervasive way. So let me quickly go into the architecture, and unfortunately with the laptop snafu, I'm not going to be able to show the demo, which would make it, I think, a fair bit clearer. But for all the projects and things that we have, it really comes down to a couple principles. Number one, like we learned from certificate transparency, we need a source of truth to be able to understand what signatures exist and to be able to see that if Krob signs something, do I see the same signature that Brian sees or that Michael may see? How do I ultimately know that I'm not being handed a one-off and trying to be tricked to use something that isn't necessarily the same global view that the rest of the world has? So in the same way that certificate transparency solves this using some technology called Merkle trees, which is, again, very similar technology underneath Git and many distributed systems today, it hashes together individual entries and basically forms a tree structure that provides an integrity over the entire tree. So you can't modify any single node that exists in the tree without altering the computation of the entire tree itself. So it gives you some assurance that this ledger or this transparency log, as it's called, has fundamental properties, being that the entries that are already there can't be edited. I can only append to the last node of the tree, and anybody who has access to the log can independently compute the integrity of the log. So you're not having to trust me to say, yeah, I didn't edit anything. You just take my word. It's good. You can actually independently go through and make sure that you see the exact same thing that everybody else sees, and that it is not only valid, but its integrity has not been violated. So that's our Recore project that holds that information about digital signatures at large. Now again, any of those items that I listed in my earlier chart, SBOMs, artifacts themselves, build provenance statements, Git commit information, anything that you can sign, you can ultimately wrap a digital signature around and upload the information about that signature into Recore. One thing I want to call out though is that we're not, with very few exceptions around some attestations, we're not actually storing the content itself. We're not trying to distribute software across the entire internet. We're trying to store metadata about this digital signature surrounding that piece of software, or that artifact, or that document. So we're not trying to be a content distribution mechanism for the net. We're simply just saying we want to make sure that people have a shared view as to the digital signature metadata that's around it. The other thing that Let's Encrypt did was they made it really, really easy to get a certificate. And in the digital signature landscape, it's a slightly different type of certificate in that it's meant for code signing rather than for web traffic and encryption. So we need to actually have what's called a certificate authority, be able to issue code signing certificates. And whenever you issue a certificate, you fundamentally have to marry key material, the public key that's used, as well as the identity of who holds the possession of the private key that is paired up with that public key. The code signing certificate contains that pairing and allows people to understand the relationship for who signed what artifact with which key. And so the code signing certificate authority that we have within Sigstore is called Fulcio. And so simply it marries in identity information that is actually represented in the OpenID Connect identity token format. This is the same exact format if you've gone to a website and you've said, hey, I want to log in with Google, log in with Facebook, log in with whatever provider. What's happening behind the scenes is you're not passing your credentials to Google or Facebook. You're going in, you're logging in, and then that provider is making an assertion to say, Joe showed up and logged into my site for the purpose of accessing your site at this given point in time. So what we do, and I would have shown you in the demo, is we have the ability, it's not the sole capability of what we have, but we have the ability to give a very similar flow. Whereas if I want to get a code signing certificate, we can launch a browser and say, let's go get an identity token from a provider that you already have an account with. And we can take the identity information of this particular individual has an email address at Google, for example, and we can use that as the identifier that we put inside of the code signing certificate. The other really cool thing that's been going on that's an industry trend that I mentioned earlier as well is this concept of workload identity. And it's been really nice to see the cloud providers as well as the broader security market really rally to reusing this OpenID Connect identity token format to represent the identity of workloads. So in the same way that we can support developers going and getting a token from Facebook or Google or Microsoft, we can also support going to a GCP workload identity provider or an AWS identity provider, getting a same token and putting that information into the code signing certificate. So instead of saying Joe signed this document, it's actually this CI workflow running on GitHub Actions signed this document, which again, you can start to put other information with, which is which run on which repo actually generated this signature, what Git commit was associated with what triggered this run to start on this CI system. I can now actually have a much richer set of information that's cryptographically secure, issued within a code signing certificate from Fulcio, that then anybody who comes along and looks at my artifact can see this thing was signed by the appropriate GitHub action that was managed by the community associated with this artifact, not some random email address on the internet. So we have the flexibility to adapt to different models, and projects are at different points in their life cycle. Some projects still want to be able to associate to humans that are the release managers and the release engineers for a given release, and they want to have that association and build their trust model in that way. Again, like, totally cool. Other people want to go to a model to where just trust the builder. We don't want to actually trust that there's a human in the loop here at all. There's too many risks of tampering in that model. So we actually support driving that flow again through the workload identity construct. And then finally, to pull all of this together to address this usability challenge with PGP and OpenSSL, and if you've ever used those tools, you're probably nodding along with me. They're not the most usable things in the world. We wanted to re-envision what that experience should look like for a developer. How do I sign things and how do I verify things? And when we started, we built, the first tool for this was called Cosign. And by the name, you can imagine the relationship between containers and signing. We saw that was a huge opportunity to try to pull digital signatures into that ecosystem. And so we built Cosign to be able to sign a container, store that information inside of an OCI compliant registry. And that project has gone off like wildfire and is starting to be widely used across much of the container ecosystem. But in addition to that, it's written in Go. It's a 80-something meg binary at this point. Like, all Go binaries tend to be a little bit beefier than others. If you go to the Java community and you go, we have the software signing solution for you, and it involves a 90 meg Golang binary, you can imagine how that conversation goes. It doesn't go very far, and they go, thanks, cool idea, next please. So what we recognize as we started engaging with these communities is we need to meet people where they're at. We need to meet the Java community where they're at, the Rust community where they're at. And so we've built out a set of ecosystem-specific clients that all implement the same fundamental logic of how to go get a certificate, how to put that certificate into the log, how to actually sign the artifact, how to publish it to the distribution system for that ecosystem, but do it in their native language. And so we have clients built around Rust, Java, Go with Cosign. When we have many more that are already under development. Python is another one that I would have shown you in the demo today. But in general, we see a massive amount of ecosystem clients being generated to meet each of these individual communities where they're at and adapt to the trust models that they're comfortable with. So again, we're trying to bring the same fundamental principles, but make sure that they're addressable in a very open and interoperable way. Here's where I would have kicked to the demo and shown you this. Unfortunately, I'll just quickly talk to the two things I would have shown you. One is that just last week, the latest release of Python, the actual programming language, was signed with Sigstore. And if you go to download the Python distribution, you can actually cryptographically verify that signature, verify that there's an entry in the public record transparency log associated with that. And again, a huge step forward. They had actually signed with PGP keys in the past. They're still actually signing with PGP keys to give their folks a chance to experiment, understand, and get comfortable with it. But that was one thing I was going to show you, was what does that experience look like native within Python. The other thing was I was going to show a quick CI/CD demo, and I'm going to try this on the fly, because now that I'm up here thinking, I think I can get to at least show you a previous run of this I did this morning while making sure everything still worked. So what this was is I have a very simple Go program that just basically said, hello from Dublin. I pushed up a change to that program, and I allowed GitHub Actions to actually compile that Go binary, put that inside of a container, sign the container, publish that to a container registry, as well as publish the signature out to a Recore instance. So if I drill into this GitHub action here, there's a couple different steps. I install a couple different tools. I use a really nice tool called KO, which takes a Golang binary, puts it into a container in a really simple and straightforward manner off of a very minimal base image, so you get some added security there. It also generates you an SBOM as part of that, which is kind of cool too. So now we have this rich container that has an attestation. It has the actual binary, again, wrapped in a distroless image, and we then call out to Cosign to sign that container, but not with any human key, not with a physical UB key. We actually use the identity of this CI run on top of GitHub to marry together with the full CO service, get a code signing certificate. And even though it's a lot of text up here, what's happening at the end of the day is I have a container in a registry that is signed. Anybody can go verify the integrity of that signature, verify that it's actually in a log and that it's the same thing that everybody else sees, and ultimately get to a point to where they can have a lot more confidence about putting that container into their prod environment. And we're starting to see projects both within Sigstore as well as within the broader Kubernetes ecosystem come together and actually use this information in the context of admission controllers. So if you think about how do I write webhooks that can ultimately make dynamic decisions, we have examples of that within the Sigstore community, and new products even coming to market that are based on this sort of pattern. So I think it's a pretty exciting capability, and to be able to do this without actually ever touching keys. There is a public and private key used in this. It turns out that they're ephemeral. I can throw them away after I've used, and the certificates actually have extremely short lifetimes associated with it. And so that really, you don't have to worry about revocation of key material when you do that as well, which is a super powerful construct, because again, I don't have to worry about how do I manage that after the fact. So quickly, just going back to a couple slides, one thing I wanted to stress is that while we do have that Let's Encrypt mission and spirit, these are a set of projects. You can go run any subset of this infrastructure that you like inside your own company, inside your own data centers. If you choose not to use, again, you don't have to use Let's Encrypt to get on the internet. You can still go buy a certificate from DigiSign or another vendor. We fully would interoperate with that, because again, all of this is built on open source and open standards. So while we try to make it easy and addressable for open source developers across the web, there's no requirement that you have to use our services. You don't have to log in with Facebook or log in with Google. That's not a requirement to take advantage of the benefits that Sigstore brings to bear. I mentioned this cool like ephemeral key construct, which has a lot of benefits associated with it. If you still you're like, hey Bob, I get it. I got a YubiKey. I think I can take care of my YubiKey. Thank you very much. You can still use it with our stuff. Again, it has a public key and a private key in it. There's nothing fundamentally preventing you from using this. And we actually have the capability within our tooling to be able to interface with those hardware key modules, HSMs, and pull all that together. And then finally, a lot of what I showed in the brief snippet there, the demo, it does show an online verification model. We do recognize that not everybody is always going to have a constant connection to the internet and be able to reach out to public services. So we also have the ability to do offline verification of this information. So if you're able to import a public key that you're known to trust and a root that's associated with that public key, you can actually do the verification of all of our signatures in a totally offline construct as well, which is super powerful. So the last couple things I want to mention is that, as I said, this community is growing like wildfire. We actually have our first user community event coming up here in a little over a month, co-located with KubeCon in Detroit. We're going to have a mix of speakers, some introductory level content, some overviews of different use cases where different communities and companies have started to play with the technology, and they're going to give their experience in doing so. And then we also have a couple talks that are really technical deep dives around how different components within the infrastructure. If you're able to join us in Detroit, we'd love to have you. If you're not, all the recordings will be available on YouTube, so I would encourage you to take advantage of that. And then finally, we are a growing community, a wide set of companies, a wide set of diverse individuals that are there. We have folks from academia. We have just interested programmers from along the web. We may have the Libraska person, I don't know. But in general, we're a fun, fast-growing, diverse community that is making good stuff happen. And so I would strongly encourage you to take a closer look at what we have with Sigstore. We have great documentation, blogs, a set of projects under GitHub. So lots of ways to get in touch with us and engage. And with that, thanks for your patience with getting the laptop snafu set up and resolved, and thanks for your attention.